notes out because we'll do our exit ticket in a minute later. On your whiteboards, go ahead and solve for x to nearest 10th. Hold it up when you have the answer. First two people each time get Eagle Bucks. Are you ready then? What is that? No. This one was wrong? Yes, very good. First one. Very good. Second one. Very good, Zion.
I forgot to do the
Square?
Yeah.
It's kind of important. Keep going. I want to know who knows how to do this and who doesn't. Perfect. Awesome. Try your rounding again. Try your rounding again. It shouldn't be a comma, it should be a number, a whole number. Good. Thank you. Try your rounding again. Very good. Here's 10. 10 has how many zeros? 1 0, so that's 1 decimal place. Alright, so if you did not get this one, do 12 squared plus 27 squared in your calculator. Do this. 12 squared plus 27 squared. You should get 873. 873 equals x squared. What's the opposite of squaring something? Square rooting. Good job, Jose. So, you square root both sides. You take the square root of 873, and you get 29.54657, blah, blah, blah. We're rounding to 1 decimal place. So you ask your neighbor, hey, 4, do I bump up or do I stay the same? And the 4 says, stay the same. 4s don't bump numbers up. So the final answer was 29.5. 29.5. Okay, try this one, please. Uh-oh. The numbers are small.
How do you do that one again? You subtract, right?
Yep. Good. First one. Good. Second one. Nice. Are you happy? Thank you. Remember, the hypotenuse is always across from the right angle. 5 is the hypotenuse. It's not a leg. Try again. Try again. So if you're doing a squared plus b squared equals c squared, it should look like mine. C, x is not c. Oh, yes, I told some people the wrong thing. Yes, and I think you had it right too. No, you had it right. You have it right. Very good.
Man, why
So you subtract, or we could go ahead and simplify it. What's 3 squared? 9. What's 5 squared? 25. So x is not by itself. That's a problem. So we need to subtract 9 from both sides. X squared equals 25 minus 9. 16. Very good. And then you always, the last step every single time, Jared, is what? What's the last step every single time?
Square root.
Square root. Square root is always the last step. What's the square root of 16? It's a beautiful answer. You didn't even need to round. It is 4. This is actually called a 3, 4, 5 triangle, even though it's not to scale. Look, the 3 is longer than the 4. Sorry about that. Anyways, it's a 3, 4, 5 triangle. That's called a Pythagorean triple. We'll learn more about those later. All right, last Pythagorean theorem problem. Then we'll do some distance. Find x to the nearest 10th. You can do it. Yes, very good. I got it. Nice, second one, good job. Pythagorean theorem pros in here. Yes, perfect. Good job. Try again. Try again. You got the same thing. Did you add those? 30 squared. Okay, but we can't add them because 30 is the hypotenuse. So it's x squared plus 6 squared equals 30 squared. It's a subtraction one, not an addition one. Good. Yes. Good. Good rounding. Perfect. Good job, Marisol. Should be doing 30 squared in your calculator minus 6 squared. Because when we're looking for a leg, we subtract. Perfect. And then you square root. Next one. Oh, next one is what you're saying. Look at your rounding again. Okay, just put that away, okay? Can you look at that later, please? So, you should get 864 equals x squared. And then you take the square root of 864, and you get 29.39387. You look at the 3, you ask your neighbor, do I stay at 3 or do I bump up? And his neighbor says, bump up. The answer was 29.4. Yes, Trent, it was 29.4. Okay, distance, let's go. Let's see if you can do it. Remember, circle your x's and underline your y's. Who's going to be first?
Do you have to put parentheses there?
Yeah, do your skeleton. You want me to do the skeleton for you? I can't always do this.
No, I'm saying, do you always have to do that's like a big part.
Yeah, those parentheses are a big part, yes. Nice! Well, don't give up now. You still have to show me you know how to do it. Nice, very good. Love this. Good job. You got it. It is a whole number. The answer is not a decimal. It's a whole number, by the way. Yes, very good. Oh, that just means when you press enter, you're going to get a nice pretty number with no decimal places. Good. 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 Oh, you're just subtracting it. Make sure. Don't put a comma. That's 3 squared plus 4 squared. Square root of that. Good. What page? 164. Okay, so did you put 5 minus 2 and 4 minus 0? Did you put those?
Oh, I didn't put the squared.
Yes, squared is very important. So that's the square. Let's see. 5 minus 2 is 3, and 4 minus 0 is 4. So you're doing the square root of 3 squared plus 4 squared. And the final answer was? 5. The answer was 5. Another 3, 4, 5 again. Wait. Oh, yeah.
5 minus 2 in the calculator. And then, am I supposed to like square that part too?
Yeah, 5 minus 2 squared plus, do plus, parentheses, 4 minus 0 squared. Good. Enter. Yay, good job, Paige. All right, next one. You have the chance to be first. Still have a chance. So you're saying there's a chance. Whoa. He beat me. Oh my gosh, are they just a minute? I'm not ready.
Well, they already had us like square root.
Okay, show me again. Don't say it out loud. Oh my gosh, so quick. Yes. Try again. You are second. Try again. Yes. Man, speed demon over here. You did someone else's. I'm smarter than that. Yes, good job. Very nice. Y'all are going to ace this quiz tomorrow. Yes. Oh, okay. Let me see. Oh, here you did it perfect. minus a negative. Here you did a minus minus, and it doesn't like that. So I'm going to press entry. I'm going to pull it back up. Instead of that, it makes it negative, like you did on the other one. You did one of them right, the other one wrong. Good job. Yes. Yes. The answer is lucky number 13. The answer is 13. You should have done 3 minus negative 2 and 8 minus negative 4. In your calculator, look and see where the minus is. Do you see where the minus is? The minus is above the plus, the minus. But then the negative is different. The negative is under the 3. The negative is like that. So when you do a minus a negative, it should look like that in your calculator. Your calculator gives you an error if you try to do minus minus. So make sure you know the difference between those. All right, let's do a midpoint and we'll move on to today's lesson. Last whiteboard problem.
I don't get how on the other one, I don't get how you got 13 and 12.
How we got 13 on this last one? Okay, square root of, parentheses, 3 minus 2 squared plus, and you didn't put squares on that one, but 8 minus 4 squared. 15. You just type in, you have to type in all of this, you have to type the square root, the squared, the plus, the minuses. You just type in every single thing. Oh, I wasn't ready. It was Savannah and try it one again. Savannah and no, we're not. Okay. One of them is a decimal. Circle your x's and underline your y's. Add your x's and divide by 2. Add your y's and divide by 2. 13 divided by 2, good. 6.5. Let's see. 2 divided by 2. What's 2 divided by 2? 1. So the answer was 6.5, comma, 1. All right. Can you get out your notes packet, please? We're going to do patterns today. Linear patterns. We're going to be on the page that says Notes, Nth Term Linear. Notes, Nth Term Linear. Probably did this in algebra a little bit last year. So tomorrow, just FYI, tomorrow your quiz is over Pythagorean theorem, distance, midpoint, and endpoint, which is leapfrog, okay? That's what your quiz is over tomorrow. First grade of the 6 weeks tomorrow. All right, nth term linear, here we go. So, a linear equation is simply an equation with a degree of 1, and the graph is a line. So, linear equation, you can write in where it says linear equation and there's just empty space, you can just write degree of 1, and then you can write the word line. You don't have to write the whole sentence. I would put degree of 1 right here, degree of 1, and then put line. Linear and line go together. Linear equation, degree of 1, and then line. Here, right. Here, linear equation, degree of 1, and line. Oh yeah, it goes right there, sorry. Degree of 1, and line. So, what are some examples of a linear equation? Let's look at the examples and we'll decide if they're linear or not linear. First one, y equals 2x plus 7. Does it have a degree of 1? Does that say x to the 1? Do you know how a 1 is understood? Like if you don't write the 1, it's just understood. That's not a 0, it's not a 5, right? So this one is an example of a linear equation. So add that one to your examples. Y equals 2x plus 7 is linear. Where it says examples, write y equals 2x plus 7. Okay, next one. 39.5 minus 10x equals y. Does it also have a degree of 1? Is it okay that I have decimals in there? Sure. Write it under your examples. Linear. Yes. Linear. Yes. Don't let the decimal scare you. It's still linear even if the y-intercept is a decimal. So 39.5 minus 10x equals y. Okay, next one. X squared plus y equals 5. What is the power of x? What's the power? 2. It's x squared. So is it linear? No. What is it? Quadratic. So don't write that as one of your examples. That one is not linear because it's x to the 2. Last one. X plus y equals square root of 23. Is it x to the 1? Yeah, it's still x to the 1. So that one's linear. They were all linear except for number 3. As long as you wrote down just one example, you're fine. Okay, so when a pattern's linear, we can actually predict the future of the pattern. So we love when patterns are linear because we can find out what it's going to equal way, way, way down the road. So we're going to be predicting the future today. So write the word linear and write the word predict the future. It is algebra. Linear and predict the future. It's a review. Linear and predict the future. Okay. All right, so Dino, I don't know how you say that. What do you think? Dino? He works out regularly. When he first started exercising, he could do 10 push-ups. After the first month, he could do 14. After the second month, he could do 18. And after the third month, he could do 22. Predict the number of push-ups Dino will be able to do after a year of working out.
He's weak.
What? He's weak. But he's getting better. He's growing. So we don't really need to solve this yet. I just want to know ideas of how we would solve this. What would we need to do to find out how many push-ups he can do after a year of working out? What would you do? Make a table? Does that sound good? What would we do in that table? What would we be looking for?
Well, first of all, we find the pattern.
The pattern.
And then we would divide that by how many years. I don't know.
So each month he is doing more and more push-ups. How many is he doing
4.
each month? 10 to 14 to 18 to 22, what did you say?
4.
4. So he is going up by 4 every month. So that is going to be like our slope in our equation. Our slope. Okay. So let's see if we can find out how many push-ups he can do after a year. So after 0 months, how many could he do when he first started? 10. So the value is 10. 0 goes with 10. And then he could do 14, and then he could do 18, and he could do 22. So we're going to find out how many he could do after n months. So you did this in algebra. You had a process column. You had a term and a value. What did you do in algebra? What did you do first? Delta y. Very good. Yes, very good job. So we're going to find delta y, which we've kind of already found. Oops, sorry. Jacob helped us find it. We're going to find delta y. The way you find delta means change. It means subtract. So we're going to subtract. What's 14 minus 10? 4. What's 18 minus 14? 4. What's 22 minus 18? 4. We now know that our pattern is linear because we got the same number every time. Our pattern is now linear. So 4 is our slope. I want you to write it all the way down the row. 4, 4, 4, 4, 4. All the way down the column, pardon me. 4, 4, 4, 4, 4. The next thing you do is in parentheses, you write the term. 0, 1, 2, 3, and n. So go ahead and in parentheses, write the term. 0, 1, 2, 3, n. The next step I like to call the tweaking step. Tweaking. So, what is 4 times 0? It's 0. How do you make 0 look like 10? Add 10 to it. 0 plus 10 is 10. You add 10 to it. Let's check the next one. What's 4 times 1? 4. How do you make 4 look like 14? You add 10 to it. And once you've checked it twice, you can write it all the way down the column. You're going to be just like Santa. You're going to check it twice, and that's all you need. Making a list, checking it twice. All right, so they asked us how many push-ups he could do after a year of working out. How many months are in a year? 12. So go to your equation, which is right here, and instead of in, put 12. 4 times 12 plus 10. Is he weak now? What'd you get? He can do 58 push-ups after 1 year. So that's how we predict the future with our linear equation. 58 push-ups. Questions? 12. Oh, it says how many could he do after a year of working out? These are months right here. These represent months. So we can't put 1 in for 1 year because that's not how many months it is. How many months are in a year? 12. I'm not saying it's realistic. Just pretend. Okay. Try the next one. Ready? This one is actually a real life thing. Did you know that the speed at which a cricket chirps is affected by the temperature? No. It totally is. It's a real nature thing. So every time, as it gets colder, the cricket does not chirp as often as it gets colder. As it gets warmer, he can chirp a lot more, a lot faster. So anyways, every 14 seconds, here's how many times he chirps, and that's the temperature. We need to find an equation so we can predict what the temperature is outside without even having a thermometer, just by listening to a cricket chirp. All right, so what do we do first? Delta y. We're going to do delta y. We're going to subtract. Change in y. What's the change from 45 to 55? 10. 55 to 65? 10. That's good. That means it's linear. Now this one's a little bit different. Our last one went 0, 1, 2, 3. This one goes 5, 10. Oh. Delta x is not 1. So we're going to find delta y, but we're also going to have to find delta x. How far do you travel from 5 to 10? 5. You can always subtract to find this number. 10 minus 5 is 5. 15 minus 10 is 5. All right, now we need to find our slope. And our slope, we're going to talk about this way more on Wednesday. Our slope is always delta y over delta x. I'm going quickly because you already learned this last year. Okay, what is delta y? Thanks, the whole class, for yelling that out. 10. What is delta x? 5. What's 10 divided by 5?
Wait, 10
What's 10 divided by 5? 2. Write 2 all the way down the row, and then go home and practice dividing tonight. Oh my heavens. There are 2 5s in 10.
Wait, did you put like 0, 0, 5, 10?
Yeah, that's what we're going to do next is you write 2 all the way down the row because that's your slope. Now you write your term. 5, 10, 15, and n. I'm just stealing those from that column. I didn't make those numbers up. I just stole them from that column. 5, 10, 15, n. The last step Miss Tanton calls the tweaking step. We have to tweak it to make sure that it works. 2 times 5 is 10. How do you make 10 look like 45? Subtract them. How do you make 10 look like 45? Subtract them. 45 minus 10.
35.
Plus 35. How many times do we need to check it? Twice. Let's do the next one. 2 times 10. 20. How do you make 20 look like 55? Subtract them. 55 minus 20. You should get 35. And so now that we've checked it twice, we can write it all the way down the column. So our answer is 2n plus 35. And now we need to see what they're asking. If you hear 32 cricket chirps, what is the temperature? So instead of n, you're going to put 32. Go to your calculator. 2 times 32 plus 35.
99.
And it is a summer day in Houston. Right? 99 degrees outside. Houston summer day when the cricket chirps 32 times in 14 seconds. Okay. That was fun. Noah. Noah makes money tutoring in geometry. Did you know tutoring, you can make big bucks? I did that throughout college. That was my job. Anyways, each month he adds an extra hour to his tutorial schedule. If the trend continues, how much will he make in his 11th month of tutoring? This one, yep, this one's on yours. Okay, good. So, what do we do first? You know what to do. You know the drill. Delta y. The way you find delta y, delta means subtract. So you should be subtracting 116 minus 108. 124 minus 116. 132 minus 124. If you get the same number each time, it's linear. Did you get the same number each time? What did we get? What did we get? 8. So 8 is our slope. The reason why 8 is our slope is because what is delta x? 1. It's just 1. So we don't need to worry about delta x this time. It's nice when we don't have to worry about that. Alright, so our slope is 8. And now we need to do the tweaking step. They didn't give us a process column. So we're going to have to go to the bottom and kind of do the process column ourselves. So we're going to plug in 1 month. And 8 times 1 is 8. How do you make 8 look like 108?
Subtract.
How do you make 8 look like 108? Yeah, you can subtract them. 108 minus 8, and you should get 100.
No.
So that's our equation. 8n plus 100. How many will he make in his 11th month? How do you find that out?
188.
8 times 11 plus 100. You take 11 and you put it right here. So he's going to make $188 just by tutoring in geometry.
In the 11th month.
No, in the 11th month. He's making more each month because he keeps adding hours. So in 1 month, he'll make that. $188. Put a dollar sign. Make sure you put your units. Okay. What is going on here? Flip your page. Oh, no. Don't flip your page over. It just kind of got cut off at the bottom. See it? Here are the first 3 stages of a circular pattern. It's kind of pretty, huh? How many circles would you find at stage n? Oh my goodness, they didn't even give us a table. So we're probably going to have to make our own table. Yeah. So I would put stage, and then I would put circles. And I'll leave room for a process column.
147.
Stage, circles. Thank you for counting, Jacob. Stage 1, stage 2, stage 3. I'll do stage n. So we can find out how many happens at the end stage. Alright. So Jacob counted them for us. What was it in stage 1? 1. Stage 2?
4, 7.
Stage 3. Okay. 1, 4, 7. Jared, what did you get for delta y?
Well, I didn't do it.
We'll do it right now. What's 4 minus 1?
4 minus 1 is
3. 7 minus 4?
3.
3. Yay, it's linear. We got the same number both times. It is linear. So 3 is our slope. 3 is our slope. Now we do the tweaking step. 3 times 1 is 3. How do you make 3 look like 1? Minus 2. Check it twice. 3 times 2 is 6. How do you make 6 look like 4? Minus 2. So now you can write it all the way down the row. Minus 2, minus 2. So our pattern, our rule, sorry y'all didn't have a lot of room on there, is 3n minus 2. That's our rule. That's our pattern. 3n minus 2. So, Claire, give me a number. What? 10. Everyone find out how many circles are at the 10th stage. 3 times 10 minus 2. There would be 28 circles, and I'm glad I'm not in charge of drawing that. 1, 2, 3. That would take a long time.
85.
85?
The answer.
The answer is, how many circles would you find at stage n? That's this, 3n minus 2. That's the answer. And then Claire said, how many would we find at stage 10? And you just do 3 times 10 minus 2. It's 28. We just made that one up. Okay. We're going to keep going. I know we're running out close to out of time, but we don't have any homework tonight, so we're going to keep going. What's wrong? Sometimes our patterns are not going to be linear. We're not in Kansas anymore, Toto. Sorry. Sometimes they are going to be very good. Quadratic. Everyone put quadratic. Sometimes they will not be linear. They will be quadratic. So what is a quadratic equation? Yeah, a quadratic equation has a degree of 2, just write degree of 2, and it's a parabola, not a line. So a linear equation is a line. A quadratic equation is a parabola. So just write degree of 2 and parabola next to quadratic equation. Degree of 2, parabola. Degree of 2, parabola. I'm going to reveal all the examples. Oh, never mind. And you decide which ones are quadratics. I'll give you a hint. 2 of them are and 2 of them aren't. On number 4, that says 1 over x squared plus 3 equals y. And you'll learn later in Algebra 2 that when a variable is in the denominator, that gives it a negative exponent. So that's like saying x to the negative 2 plus 3 equals y. So that's not a parabola. You can't have a negative 2. So which ones are? Number 2 and number 3. So if you want to write down examples, you're welcome to write those down. Those are parabolas. The other ones are not. Betty, who wants you? Who wants it? What's Betty?
Oh, yeah, keep going.
Hey Betty, we're on a new page. Quadratics. What are you going to do if you don't know how to do these? I'm worried. Okay. Let's actually try one. Let's see what's different about a quadratic versus a linear. First thing I want you to do is take those numbers, that pattern, and fill them in the table. 3, 18, that was a weird 8, 43, 78, 123. You'll notice that these grow a lot quicker than linear ones. They grow faster. Now, what did we do last time to start with, every time? Delta y. I want everyone to do delta y. Oh, I did not mean to press that. 18 minus 3. 18 minus 3 is 15. 43 minus 18. Oh. 25. 78 minus 43. 35. And 123 minus 78 is going to be 45. Oh no! We didn't get the same number for delta y. We got different numbers. That's how we know it's quadratic. How do we know it's quadratic? Different numbers when you do delta y. So you know what you do? Delta y. That's what you do. What?
Are you recording?
Yeah. Delta y. What is 25 minus 15? 10. 35 minus 25. 10. 45 minus 35. Oh, thank goodness, we got a constant number. Delta delta y was constant, therefore we have a quadratic equation. All right, now be careful. 10 is not your slope. Everyone say 10 is not my slope. We did delta y twice, so we need to kind of undo that. We need to divide by 2 because we did delta y twice, so we need to undo it. So what is 10 divided by 2? Are we going to have trouble dividing again? It's 5. 5 is our slope, so write it all the way down the column. 5 is the slope. It's not 10. The biggest mistake you could make is to forget to divide by 2. There's another 2 that we have to do. That rhymes. Another 2 we have to do. We have to square our term because quadratics are x squared. They're not x. So instead of writing 1, 2, 3, 4, 5, I'm going to write 1 squared, 2 squared, 3 squared, you get the idea. 4 squared, go ahead and write it down. 5 squared, 20 squared, and n squared. Go ahead and write that down. It's quadratic, so we have to square it. 1 squared, 2 squared, 3 squared, 4 squared. Last step is always the tweaking step. 5 times 1 squared. Well, 1 squared is just 1. So 1 times 5 is 5. How do you make 5 look like 3? Minus 2. Check it twice. What's 2 squared? 4. What's 4 times 5? 20. How do you make 20 look like 18? Oh, thank goodness. We got the same thing both times, so write it all the way down the column. And the answer is 5n squared minus 2. 5n squared minus 2. Go ahead and plug 20 in and see if you can get that one correct. 5 times 20 squared minus 2.
1998.
It should be a big number, yeah. 1,998. Yep. See how quadratics get really large really quickly. Some people, this helps them remember to divide by 2 and then square your number. We call it the 2-2 rule. There's 2 2's that you have to do. You have to divide by 2 and you have to square your term. So there's 2 2's that you have to do. So it's called the 2-2 rule, like a tutu, like a ballerina. So if that helps you remember it, then there you go. Try the next one by yourself. Everyone should be doing delta y. And then it's not going to be the same, so you're going to do delta delta y. When you get a chance, look at the board and make sure yours looks like mine. If you have 2 written all the way down the column, you didn't do the 2-2 rule. You have to take delta delta y and you have to divide it by 2. Delta delta y is 2y, so you have to undo it. You have to divide by 2. You should have written 1 all the way down the row. And then you square your term. And guess what? The tweaking step 1 squared already equals 1. It's plus 0. And 2 squared already equals 4. And that already equals 9. So it's actually, the tweaking step is not even necessary. So your nth term you should have gotten is just n squared. You can write 1n squared plus 0, but the 1 is not necessary and the 0 is not necessary. So the answer is actually just n squared. So what would our 20th term be? 20 squared. 400. Woo! I know. So how do you tell the difference between a linear and a quadratic pattern? How do you know? If I didn't label it, how would you know whether it's linear or quadratic? What do you think?
Constant.
What's constant?
The linear is more constant.
What about the linear is constant?
Slope.
The slope, the delta y. If you do delta y and you get a constant, boom, it's linear. If you do delta y and you get a constant, boom, it's quadratic. We will leave off right there. We'll do the other examples tomorrow.